Hello, welcome everyone to the NPTEL course of Climate Change and Extreme Events. Today is the summary of week 1 and we will also discuss about the assignment 1 of week 1. And in this particular summary lecture, we will go through whatever we have so far covered in lecture 1 to lecture 3 in the first part of this presentation. Then in the second part of the presentation, we will talk about there is a one assignment, so you have to do it yourself after watching this video, and then you can basically there are several objectives of this assignment. You can complete that objectives and then we can discuss further on the solution of this assignment in the next class as well. So in the past 3 lectures, we have already discussed about several different properties of climate, weather, and their differences, and there are different types of examples as well. In the lecture 1, primarily we covered the climate science basics, primarily what is weather and what is climate. And for example, we had discussed what is weather. Weather is a short term temporal phenomena for a very localized region and has a very higher variability as well. On the other hand, when you are talking about, let's say, climate, we are saying this is a long term phenomena averaged and for covering the regional or the global scales as well. In the weather system, we have already covered there are several parameters which are basically influencing the weather behavior of certain region or certain location. These variables are, for example, the atmospheric pressure, the temperature, the humidity, the wind pressure, wind pattern, etc. These are some of the weather's parameters which defines what exactly the weather condition of one particular location compared to multiple other locations of other part of the world as well. On the other hand, when you are talking about, let's say, climate are influenced by multiple different types of factors. For example, what is the position of that region according to the latitude, higher latitude region or mid latitude region or lower latitude regions, like that. Then we will also have talked about what is the elevation differences of different region, whether what is the climate of the region which is highly elevated and what is the climate of the region which is not that much elevated, or maybe the flat regions, for example. Then we have also talked about various different types of currents which transports energy from one location to energy or heat from one location to the another location, and that somehow balance the overall earth energy system or the energy transport from the one location to the another locations throughout the globe, maintaining the overall the energy balance of overall earth. Then we have also talked about what is exactly the vegetation pattern, how vegetations can control the different types of climate behavior of different regions. We have talked about, let's say, Amazon rainforest, why it is very different from other let's say arid region across the globe, and so we have already covered it. Then we have also covered about, let's say, what is the human activities which are sometimes influencing the climate of one different types parts of the world as well. Then after that, we have also gone through what is the interaction between weather and climate. So in the summary, I have given one of the diagram here which can basically tells you about how the weather and climates are related with each other. For example, if you observe a weather conditions for one particular locations, and if you analyze the weather pattern for multiple different time period or weather patterns, you can basically get an idea about, let's say, what is the overall climate characteristics of that particular regions as well. That historical climate behavior can sometime use for predicting what is going to happen or what is likelihood conditions of different types of climate events. For example, let us say if you talk about what is the higher magnitude climate extremes, what is the low magnitude climate extremes, what is their probability of occurrence in the past historical data set, and these information can be used for understanding about what is the prediction of the future climate conditions of certain regions as well. Then based on these predictions and behavioral analysis or historical data analysis and all, we can prepare for the extreme conditions that will help us to manage, let us say, a socioeconomic conditions, or let us say managing the human resource or managing different types of the economical parameters for certain regions like that. So we have discussed about how weather and climates are interdependent of different regions, and how we have to understand these different terminologies to understand about what is exactly the climate change and all. So in the lecture 1, primarily we have covered the weather and climate differences and their interrelationship. In the lecture 2, we have further discussed about, let us say, what is exactly climate change, how we can introduce them, this particular terminology, what is climate change, how we can introduce that. We have already discussed that the climate change, if you are referring, it is basically referring to some sort of human made perturbation in climate system that is basically changes the climatic behavior of certain region, and therefore, and we also attributed that changes with certain different types of parameters which are natural factors as well as the anthropogenic factors. So when I am saying the climate change, which means it is a kind of a long term changes in the temperature, precipitation and wind pattern and other climatic elements which has been continuously shifted their behavior over the past several years, and that is basically we assess using when we are saying, let us say, the what is exactly the climate change are. There are several factors, as we have just discussed. There are natural factors which can attribute to change in the climatic condition of one certain place. There is a anthropogenic factors also which can basically alter the climatic condition of one certain regions or place as well. For example, if you talk about natural factors, these are volcanic eruption, solar radiations, ocean currents, orbital change and natural and greenhouse gases. This can basically attributed to the natural forcing of climate change in a different region. On the other hand, if you talk about, let us say, anthropogenic factors, which are fossil fuel combustion, deforestation, industrial processes, agricultural practices, waste management and all, these are the some of the anthropogenic factors which are responsible for climate change conditions in one particular regions due to human activities and all. Because of these we have already discussed in the lecture 2, and we have also discussed about what is the impact of climate change across different parts of the world as well. For example, how we can say that the climate is changing, what is the evidence of climate change, or what is the impacts of climate change across different parts of the world. So when you are saying the climate change, there are extreme weather events are increasing quite significantly. Their probability and their magnitude has been significantly increased in different parts of the world. For example, if you talk about extreme weather events, hurricanes, droughts and wildfires, you can also talk about what is the sea level rise, that is basically because of the coastal flooding or the land erosion because of the sea level rise condition across different parts of the world. We can also talk about, let us say, rising temperature, which is because of the global warming, which is directly attributed to your CO2 emission, GHG gases emissions like that. And therefore we have more frequent occurrence of the heat waves across different parts of the world as well, where the temperature basically increases certain thresholds and therefore it remains there for a very long period of time, and that basically directly affect the overall crop productivity, human health or socioeconomic conditions of that particular regions like that. Then we have also talked about what is the evidence of climate change in polar region or those regions where we have low temperature. There are quite significant occurrences of melting of ice because of the rise of the temperature, and therefore we have observed various different glaciers, particularly Himalayan glaciers or several other glaciers as well are retreating because of the change in the temperature condition. Then we have also we have seen that polar ice is melting, and therefore it is somehow affecting the the overall hydrology or the overall climate conditions of that particular regions as well. So, these are the some of the evidence of, on the basis of that we can attribute that okay, the climate change has a significant consequences on different parts of the world, and this has been resulted into different types of extreme events or climate driven acceleration of different types of processes also. So, in the lecture 2 we have primarily covered all these topics. Then we have also covered what is the impact of climate change, as we have already discussed in the previous slides as well. So, for example, there are certain environmental impacts which basically impacts the biodiversity, flora and fauna like that. There are economical impacts, for example, if you talk about heat waves, flooding events, drought events, it directly affects the economical conditions of different region. And also if you talk about, let us say, social impacts, which means how the social fabrics are or social behavior of human beings or different animals also are affected by these climatic conditions perturbations as well. We have also discussed that because of the climate change, cryosphere, atmosphere, ocean, all are the different entities are affected, and these processes which are happening in these different parts of the processes in different parts are basically also affected because of the change in the climatic conditions as well. Then in lecture 2 we have also covered the concept of what is exactly mitigation and what is exactly adaptation, how we can use the some sort of mitigation strategies and adaptation strategies to offset the effect of climate change at one particular location. We have discussed about the mitigation is basically a longer term goal where we need to achieve that strategies where that reduces the greenhouse gases at a particular location. For example, we are low carbon transportation, waste reduction, renewable energy, waste management and all that, which is basically a longer term goal where we are focusing on how to minimize the effect of climate change by reducing the greenhouse gas concentration to the environment. On the other hand, we have also discussed about, let us say, what is exactly adaptation. Adaptation is short term solution for climate change problem or climate extremes problem in certain locations. Basically, we have to talk apply the emergency management, climate resilience buildings, preparing for the sea level rise, flood protections, wildfire resilience like that. And there are certain strategies which can be considered to be part of your long term as well as the short term goal. For example, public engagement, water conservation, local foods, smart growth and all, which can be part of your mitigation and adaptation strategies as well. Further, we have also discussed in the lecture 2 about what is the different international agreements which has been signed by different countries across the globe. For example, Kyoto Protocol, Paris Agreement and various different types of agreements which has been done on global efforts for limiting the temperature rise below 1.5 degree or 2 degree like that, and also limiting, let us say, greenhouse gas emission in certain parts of the world, so that the world's temperature cannot breach a certain threshold, and therefore we may have multiple different types of extreme events in the future conditions also. Then moving forward, in the lecture 3 we have primarily introduced the climate extremes. What is exactly climate extremes? We have talked about that climate extremes are those events which has a very higher in the magnitude and but very low in the probability. However, by looking at the historical data set, we observed that the climate extremes are continuously rising, which means the probability of occurrence has been significantly altered and their magnitude has been also altered because of the climate change conditions of different regions as well. So therefore, the climate extremes can be defined as it's a significant deviation from your the average climate or weather patterns of one particular region, and that is how basically exaggerate the extreme climatic behavior. For example, if you talk about flooding event, more floodings are common. For example, if you talk about high intensity drought events, or let us say if you talk about heat waves events, these events has become more in magnitude, higher in magnitude, and higher in probability of occurrences as well. So we have further in the lecture 3 introduced what is the different types of climate extremes. For example, we have talked about some sort of meteorological extremes, which are cold wave, heat waves, extreme rainfalls. Then we have also talked about some types of hydrological extremes, which is floods and droughts. Then we have also talked about the climatological extremes, which is, let's say, wildfire, hurricane, cyclones and all. Then we have also touched upon what is the impact of climate extremes on different parts of the world. For example, we have discussed about what is the likelihood scenario when there is a extreme become more frequent, and how it is going to happen, affect the migration of the people of certain location, what is the overall health consequences, what is their overall economical consequences of one particular region. And then we have also talked about, let's say, what is the overall impact of more frequent or more higher magnitude climate extremes on ecosystem, biodiversity, and various different types of feedback loops across different types of processes and different types of parts of the world as well. So this is so far we have covered in lecture 3. Then we have also covered mitigation, preparedness and adaptation concept to certain reduce the climate extremes severity at certain degrees in different parts of the world. For example, in the mitigation we have discussed about reducing the greenhouse gases emission, reforestation. In the preparedness, basically we have also discussed about, let's say, early warning system, disaster planning and all. In the adaptation, basically we have also discussed about, let's say, infrastructure resilience, sustainable water management. All these strategies we have discussed in the lecture 3. So this is the overall content we have already discussed about what is exactly started with the climate and weather. Then we have discussed about what is exactly climate change, and then we have discussed about how we can introduce the climate extremes, and how we can classify them, and how we can basically assess their severity across different parts of the world also. So this is the summary of the week 1, where we have discussed all these concepts so far. Moving forward, okay, in the week 1 we can have one assignment where we can basically look at what is the rainfall anomaly of or rainfall pattern of one particular region, or across Indian country or Indian region, like that. So for this assignment, what you can do is basically you can get the data of rainfall from data.gov.in website. Here I have taken a screenshot of this website and I have pasted it here. As well as I have also copied the link of this particular web resource here, which you can directly open in your browser. And once you open this link, you can get the page like this. Here in this page, you can download the data set in CSV download, which is a sort of Excel format, where you can basically open this file in Microsoft Excel, and where you can get an idea about the rainfall characteristics of rainfall magnitude of monthly values for different regions across India. So this is the one of the website where this data set was updated by mausam.imd.gov.in. This is the source where this data is originated. So this is a one I have pasted a screenshot of how this data will look like. So this is the data. Here it is basically the Indian country is divided into different subdivision. For example, I have taken the screenshot of only the Andaman and Nicobar Island. Here you can see that there are years which is spanning from 1901, 02, 03 etc. till 1936, but it is covering 1901 to 2017, which is around 117 years of the data. Then you have also monthly values of different rainfall. For example, let us say you have January, you have February, you have March, you have April, you have May, June, July, August, September, October and December, like that. Then you have also the rainfall value of annual period for the whole period. You just basically you have to sum all these values of different months and you will get the value. Here it is already there. Then you have separately what is the total amount of rainfall for, let us say, January and February month. What is the total amount of rainfall for, let us say, March, April and May. What is the total amount of rainfall for June, July, August and September, and what is the rainfall amount for October, November and December. So this is how this data set will be provided by this from the data.gov.in website, where you will get the data set of monthly rainfall across different region of India. Okay. So now you can use this data set to you can identify how the weather pattern, let us say how the rainfall has been varied across different months, and then you can also talk about what is the overall rainfall magnitude of, let us say, monsoon or annual period for different regions as well. So here it is very important to clarify that when you are saying, let us say, June, July, August and September, these are the month which is classified as which we can say that it's a monsoon month, which is called June, July, August and September. This is called monsoonal months, and all other months you can assume that is the non-monsoonal month. Okay. So what we can do, we can create two categories here. One is called monsoonal months, June, July, August and September, and other months are non-monsoonal months, basically, which can be January, February, March, April and May, and October, November and December. So in this assignment we will basically calculate how do the annual monsoon and non-monsoon rainfall time series behaves for two different regions. So in the previous slide I have described about Andaman and Nicobar region. If you scroll through that particular data set, you will get multiple different types of rainfall information for different regions as well. So what you have to do is, you have to calculate the annual monsoon and non-monsoon rainfall time series for two different regions. What is time series? You have to calculate the values for different years, and then you have to plot in x and y. In x axis you have to take all the years 1901, 1902, 03, 04 till 2017, and in y axis, let us say if you are plotting the annual data, that is the annual magnitude, and your in x axis your years. Then for similarly for the monsoon rainfall, you have to plot what is the total amount of rainfall happened during the monsoon month, JJAS, and the x axis you can plot number of years. Then in the non-monsoon rainfall time series, you have to add other months which are not falling in the monsoonal period, which means except June, July, August and September, all other month, you can sum the data and you can make a one value for each different years, and then for the non-monsoon month you can plot the x and y plot, that is line plot, where y axis is your non-monsoon rainfall and x axis is your years, like that. So these are the three map figure you can create based on these data set for two different regions, and then you can write about some sort of specific characteristics. Let us say in certain region you see that the annual rainfall is continuously rising, or the monsoon rainfall is continuously rising, or let us say it is decreasing, or it is more or less stable, like that, or non-monsoon rainfall is continuously increasing or decreasing or stable. You can write all these points in your one file. Then you can identify the years in which you have extreme rainfall events occurred during your monsoon and non-monsoon period, also for two different regions. So you can identify those years where you have very sharp increment of rainfall in the monsoon as well as the non-monsoon period, and you can just write down those numbers, or maybe you can highlight in your graph as well. And you can also quantify, let's say, what is the percentage of monsoon rainfall to the total annual rainfall. This means you have monsoon some x amount and you have annual is, let's say, y amount. You can basically calculate what is the percentage of x amount with respect to the y amount, and you can calculate in the percentage format. Let's say it can be 40%, 50%, 60%, 70%, like that. So you can quantify this percentage contribution of monsoon rainfall for these two different regions, and then you can also plot in a time series data set. In x-axis you have years, in the y-axis you have monsoonal contribution, and that you can show that what is the overall what is the overall changes in the monsoonal contribution of rainfall in different parts of the into different parts of the region, like that. So this is what the assignment 1 is, and you can go through this particular problem. You will learn about how you can see the climatic behavior has been changed across two different regions, and what is the role of, let's say, monsoon and non-monsoon rainfall pattern, how the monsoonal contribution is basically has been changed or is remain more or less same, or whether, let's say, is there a possibility of non-monsoon is creating more frequent events, or monsoon events are creating more frequent events, like that. You can also identify using this sort of data analysis. In the next class, we will discuss about how we can proceed with this assignment as well. After that class, basically in lecture 4, we will talk about more detailed about different types of climatic streams and their behaviors. Thank you so much for your attention.